hope you have scanned the QR code. Okay, we'll wait for a few minutes. Okay. Um, for today's class, actually, I prepared for continue the yesterday chapters about the exponent and logarithmic functions. And I have added quiz assignment. So if you have time, it will be on. You can join the quiz until Saturday. I think Saturday 6 p.m. Saturday. So please check the quiz and uh, please read carefully the descriptions on the quiz itself and also each question on the quiz. Okay, so let's start with the feedback time yesterday. So I'm giving you these two graphs for the first question, and the easy way to look at this graph is look at the when you have the x equal 0. Right? Because if you look here, when x equals 0, this is resulting 1, and y equal 1. This resulting y equal 5. So when x equals 0, y equal 5, and x equals 0, this one is equal 1. And we have two kind of functions. 5 with power of x plus 1 and 5 power of x plus 1. Okay. So if you look here, if you want to get this 1 here, probably you will have 5x plus 1, right? Because it will be, it's not 1, sorry, it should be 2. So it should be, or you can put 2. So here, when x is 0, then this will be 5. Okay. Okay. I think this is I think clear. Okay. So okay, almost half got wrong. Okay. So I hope you read carefully questions and how to look at the graph. Okay. Okay. I hope you understand this the point. Okay. Next is you have these functions here. Okay. So first, what you are looking at is the graph of the functions minus e with power of x minus 3 plus 4 is obtained by shifting 3 units. So 3 units means this is referring to this, which means it should be to the right. Okay. And reflecting it this one here. Okay. Uh, if you want to check how the graph should be, you can check with the original e to the x like this. Let's say this is e to the x. And then if you want to make another functions that is minus e to the x, what will you do? Okay. So first check x equal 1. Check if x equal 1. This will be uh, this will be e this will be negative e. So the y should be in the negative uh, area. Right? So you can look at the function here. If this is let's say this is 1, this is e, okay, this is e, then probably this will be the negative e. So what you are going to do is you need to reflect to this, right? Okay. So every time you see uh, you need to take y in the negative form of itself, then you need to reflect about the x-axis, right? X-axis. So this should be x-axis, and then move or shifting 4 units upwards. Okay. So this is the answer. Okay. All right. Okay. And the third questions. This is we are going to have matching the graph. First thing you need to do is uh, look at the functions. Okay, look at the functions. The basic functions is the first one, the a. Right? If you look at the graph here, uh, if you remember that the if you have e, okay, if you have e, this will be your graph e, right? Remember e. Then log will be, or ln here, ln x will be the mirror or the inverse, okay? Inverse. So probably here. Should be okay. So this should be the log or the ln. We have e to the x. So something similar to this ln we will have like here for a. Okay. And actually, because I make the options different at a, then it should be obvious that should be the answer. But if you want to make sure we confirm the other graph as well, then we can reflect, uh, like for example, this b, because it's negative x, not negative of y. Then we are going to reflect to y-axis, which is this one, correct? Okay. And then this one should be reflecting about x-axis from the basic one here. So reflecting should be here, should be number one, and this should be number uh, D. It's reflecting to x and reflecting to y. So from here, going to be here, and then reflect, and make it becomes this D. Okay. So you reflect twice. So for this D, minus log base of 2 minus x. So this should be reflected to x-axis and then y-axis, or y-axis and then x-axis. Okay, any questions from the feedback time yesterday? Any questions? Before we continue? No? Okay. Uh, continue. Okay, let me continue. The uh, we have learned at least the graph, okay, for exponential and also for the logarithm. Um, and yesterday we also have learned about the law, okay, about the law. Maybe I will try to give you some example first, and then maybe going forward to the functions of exponential and logarithm. Okay, log. Let's start this simple one. Okay, okay. For the first one, what is the answer? If you want to evaluate the expression. What is for number one? You can type on your chat box. What is the answer for number one? Yeah, for this log base of three. Okay, two. Yeah. So you can look at this, and if you want to be, uh, make sure or confirm the answer, this is three with power of two, right? And we can answer that this is, or you can think like base of you have base three, and then you need to take some to raise some power and make it nine. Or if I write this as x, then x should be two. Okay, you can also think like that. Or you can also think like this one, the first one, log three and then three, and you know that you can move this to the front and then this becoming two. Okay, number two is the same way, same method. If you have like base five, and then uh, you need to raise with some power, and then it should be six to five, and it's yeah, yeah, it's kind of it should be four, right? So this will be the answer should be four. Now how about the third one here? Now it's base of four. Yeah, correct. So you can also have a fractions, right? Like in the square root, right? So if you have this x, then x should be a half. Okay. Now if you have another one, log. What's this one? So you have square root of three. The base now is square root of three. So it's actually we can actually make the base not in a like a normal numbers like one, two, three. We can have, or we can raise the base also with some power, and raise with the fractions with the negative. Okay. So what will be here? Yeah. Yeah. So it's actually we are going to have same methods, same process like this. It's going to be the same about 27. If you want to be more get clear, this will be 3 with power of 3, and this will be 3 with power of half. This is x. So we have half x equal 3. So it's x should be 6. Okay. If you want to look at the process, or if you want to maybe doing in more direct approach, how many times you need to multiply the square root of 3, you need to have 6, right? Because this will be resulting 3 and 3, 3, 3 resulting 27. So you have 6 times. Okay. But I think if you are just uh, making the form as exponent power, I think that will be uh, a faster approach. Right? Okay, now the last one here. Now you have base of 6. Yeah, correct. It's -1. So you have 6 with power of something that you should be having a result of 1 over 6. So it should be -1, right? Or if you want to maybe look at this from the log expression, this is 6 and -1, and you are going to see that it's actually -1. Okay. Okay, I think that the simple one is easy to follow. Um, let's check the other one, because you have last time we discussed yesterday, we have our log law, right? Our log law. Let's start with evaluate. I will give you two questions. Two questions. Okay, let me give you a few minutes to check your answer, and we can go move on. Okay, so we have A and B. Okay, so you can start with A, and the base is the same. Scarlet, A is 2. Okay, yeah, that's correct. How about B? Anyone got B? Okay, if you look here, first thing what you can do is um, you can take this 5 here and half here. So we'll have 2 with power of 5 for power of half left. And then we can uh, take this into our log law. So log base 8, we will have 32 multiplied with 2, which is 64. So we will have 8 with power something that is 64. So it should be 2. Okay, now how about this one? This one, if you look at 2 and 5, we can combine and become 10, right? So log base 3 of 10, and then we can, this is minus, so we have log base of 3, that is 270 divided by 10. So we'll have this, and this will be base of 3 with power of something that should be equal to 27. It's actually equal 3. Okay, so the answer will be 3. So 2 and 3. Okay, I think you guys can do it, right? Oh, okay. Okay, so let me continue. Okay, let me continue. If I have 2 with power of 6 equal 64, we can rewrite this, okay, in terms of log with base of 2 of 64 is equal to 6. Okay, and also we can write uh, 49 uh, power of negative half is 1 over 7, right? And we can write this in base of 49, right? 1 over 7 is negative 1 over 2. Okay, and then if you look closely, we can simplify this, become log 7 with power of 2, and then 7 with power of negative 1. So you clearly see that this is negative 1 over 2. That is the answer, right? So whenever you have log with base of a with power of n, and then this is a with power of m, you can write this as m over n. So you may have the answer that is not in a whole number but in a fractions. Like for example, you have log 4 8. So what will be here? If we go slowly, log, okay, 2 power of 2, and this is also 2 with power of 3. So the answer would be 3 over 2. Okay. I hope you get the idea here. Okay, if you are missing out on this one here, uh, this will be seeming to be not really clear. Okay. If I have 2 with power of log to 13, from the property of log and exponent, we know that this will be 13, right? But when you have maybe in an exam, or maybe if you're nervous on how this came through, then remember this whole thing. Okay? You can treat this as y. Okay, so if you check, so because sometimes when you look at this, your mind will be mixed between exponent and log, and you cannot clearly thinking on how to solve this. Okay, so if you want to make it into 2 with power of y or 13, then I think you can get the log 2, okay, and then 13, this is equal y, or log 213 is the same as log 213, which is, we clearly see that, okay, that actually uh, this is true. Okay, so we can make it that, okay, our uh, our answer 13 is true. Okay, this is the confirm. Same way when you have you have uh, and you have let's say 2 ln 7 like that. Remember that ln is log base of right? So when you have ln 7, this will be log with base of of 7. So if we solve this, let's move this to here. So we will log, uh, let's say 7 squared, ln 7 squared. This and ln is actually the same way we are looking at this. So we can ignore this and we can say that this is actually 7 squared or 49. Okay. Okay, let's okay, any questions? Okay. And sorry for the noise you are hearing because besides the building, there is constructions. So every morning that they are having this kind of noise. I hope it doesn't disturb. Okay, any question here? Okay, should be good, right? Okay. Okay. The next section is about if we have an equations and we have an exponent and also logarithm in the equation and how we can solve this problem. Okay, let's do it now. It's about exponential. So first is exponential equations. So let's start with if we have this expression a with power of x equal, if we have the same a, same base, then we can clearly see that x equal y, right? And this is the property of the exponent. So if we have 5 with power of x equal 1.5, we can clearly see that this is actually 5 to the power of x. This is 5 to the power of 3, that x equals 3. Okay. Same way, we have 5 to the power of 2x and 5 to the power of x plus 1. Because it has the same base 5, then we can have 2x equal x plus 1. Then x will be 1. Okay. I hope no trouble at all this part. And how about if we have a 3 with power of x plus 2 equal 7? Solve for x. So how we can solve this? Okay, remember, every time you see an exponent here, like this one here, then you can try to add log. Okay? Try to add log. Adding log here and adding log here. Then we'll have x plus 2 log 3 is equal log 7. So x plus 2 is actually log 7 divided by log 3. Or this will be log 7 log 3 minus 2. And we can just stop here because to, to get the exact solution for this log 7 divided by log 3, we have to use calculator. Right? We can just stop here. Okay, let's move on. Giving you another example. If you have 8e, okay, and then with power of 2x, and then equal 20. So solve for x. And I think this is also you need to use calculator. But let's see the process first. Let's see the process. You have 8 in the front. Okay. Probably it's best to take the 8 to the right side. So 20 divided by 8. Or we can rewrite this in 5 over 2. So e to the x is 5 over 2. And because this is e, then I think it's best to add ln at the front, right? So we can take this and then make it to x equal ln 5 over 2. And x will be ln 5 over 2 divided by 2. And I think we can just stop until here. Okay, let me just stop here for now. Any questions from you guys? Any questions? Um, okay. If you guys maybe need sometimes to take note and maybe need to go back and see the previous slides, let me know. Okay, let me know. You can write on the chat box. Okay. Um, the exponent also, it can be in the form of quadratic functions. Okay. So for example, e with power 2x, okay, negative e with power x, negative 6 equals 0. Then solve for x. Okay, to solve these equations, okay, we can imagine this is like a quadratic function. So first, we can look at this equation and probably let our e with power of x become maybe a. Okay, and then a squared minus a minus 6 equals 0. And from here, we can see that this is a minus 3, a plus 2. And that will be our solution for a. So a is 3, a is negative 2. But remember, you need to change back to e to the x. Okay? Change back, and you get uh, e to the x is 3, and this e to the x is negative 2. So x will be ln 3, x will be ln. Okay, now this ln negative here is not possible, right? Not possible. Because you remember log Log cannot have negative. This should be greater than 0. Okay. So this is not our solution. We can have only one solution here. Okay. So every time you have quadratic in exponent or in log, you need to check carefully, is this within the domain or not. Okay. So keep in mind that you need to keep in mind, okay, to check the domain. Okay, to check the domain. Okay, so the quadratic, or you can have just in linear equations. Okay. Maybe we have this 3x x plus x squared x equals 0. Okay. Okay, to solve this, probably we can take a factor out. So we take x and we take e to the x. So we have 3 plus x. Okay. So we can solve this. Okay. How to make it 0? That x is should be 0, because when x is 0, e is 1, so we can ignore e. Okay. And also, if we think clearly, we can do this. Okay, we can do this. We can divide, or we can multiply with this 1 over e to the x. And we can have x, 3 plus x directly. And why we can do this? Because uh, this e to the x is not equal to 0. E to the x cannot have 0 result, right? So it's possible to divide directly. And we see that this x is 0 and x is negative 3. And this is our solutions. Okay. And we can also check our answer, checking back here, checking x0 is 0, checking negative 3, it's become negative 3, negative 3, negative 3, negative 1, should be negative 9e, negative 3, plus 9e, negative 3. So it should be becoming 0 also. So this is, both solutions are correct. Okay, that's the exponent equations. Okay. Um, the next section will be the log equations. But I think log equation seems more complicated than the exponent. I will leave the log equations for discussion next week. Okay, next week. Yeah, I think I will leave it for next week, and you can focus on your quiz for this week. Okay, any question? I will stop until just here, okay, for the exponent. Okay, any questions or anything to discuss with? And if you have any trouble When you review chapter 3, the polynomial, finding the remainders, zeros, and all of that. If you have anything that's still confused, still have a question in mind, just let me know. You can always asking me uh, through the email. Okay, Professor, how do you solve for something like 4 with power of x plus 6 with power of x? Okay, okay, that's quite difficult question there. 4 with power of x. Okay, now the ideal way or the ideal method is by looking at uh, the log uh, solutions. But I don't think the log solutions are also helping. Uh, but the idea is, uh, I think, using the log first, and hopefully we can try to simplify first whether this is can be simplified or not. Let me just try in a few minutes. So 2, this is 2 with power. So can we write this? Yeah, this is, I think, quite complex. Or directly, I think I can directly write this as 2, uh, 6x. Yeah, and then you need to use log here. And you need to use log. Yeah, let me try later. Okay, let me try later. Let me try later. Anyway, good questions. Good questions. But I do believe we will have solution here. We will have solution. Yeah. And I think because if you see that this 6 is actually to 3, I think we can check with quadratic functions. Probably, yeah, probably. Maybe something like the a squared minus b squared, or yeah, I think we can take this sometimes to simplify. Okay. Okay, good question. Anyway, Hans. Any other question? I will try to solve this, okay, for next week. Hopefully, we have time. Okay, if there's no questions, then we can uh, go for a feedback time for today. Okay, so let me stop the presentation for now. Um, let me check first. Okay, okay. Okay, so please join in. Okay, have you joined? Have you joined? Okay. Let me go start. Okay, let's start with three, two, one. Okay. Okay. Good, good. The faster is the more points you will get. Wow. Well, half of you got true. How you get false? It's false. Okay, false. Okay, let's go next. Okay. Okay, be careful. Be careful. Okay. Three, two, one. Let's start. So evaluate the expressions. Okay. I hope time is enough for you. Okay. Several students already submitted answer. Again, one or two students not left. If this, if you still have trouble with this, yeah, we can have more review next week. And I think maybe next week I will give you another practice. Okay, three, two, one. Okay, time's up. Okay, good. So I think the other students are not involved. Okay, okay, good, very good, very good. Okay, good. Okay, last question. I think this is pretty also easy for me. And be careful. Okay. 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 So congratulations. Congratulations. Okay. Last one is not about the questions. This is just any idea or uh, anything you've been through for our basic math course. Maybe you want to complain about the quiz, or maybe it's the lecture itself. Anything you can write. Yeah, need more practice. Hopefully. Okay. 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 Uh, Practice means more practice in class, or practice like a homework, like a homework, or practice in class, like that. Okay. So I think for the exponential and logarithm, I will have more practice, because that is the one of the most difficult things when you are going to solve it in calculus. So next week we will be focused more on practice on equations, like exponent and log, before we going through the next sections. And hopefully next week we can at least finishing the exponent and log with some practice, of course, and maybe not next week finish, maybe 2 weeks. It depends on the practice, because I will prepare, I think, more practice for this section, because it's difficult. Okay, if there's no questions, then I will stop here, and you can leave the class. Okay, you can leave the class, and yeah, we don't have the midterm. We don't have the midterm for this course, so you can concentrate on other course for the midterm. Okay? We only have quiz, and the quiz itself is, I'm giving like maybe 3 4 days for finishing the quiz, so you have time to manage yourself. You have time for your own management. Okay? You can have your quiz, depends on what time you prefer, but we will have a final. We will have finals, and hopefully the final is when you are already arriving in Thailand, so I can meet you guys. If there's no question, I will stop here. I will stop here. Any questions so far? Yeah. Okay. You're welcome, Arjun. Uh, oh, Hans. Okay, you are really determined to solve that equation. Maybe. Yeah, maybe you can try that. Yeah, you can try that as well. I haven't tried anything. Okay. Because I need also to to roughly calculate first. Okay. Yeah, good thinking, Hans. Maybe. Okay, if there's I will help you maybe next week if I have solved the questions. Okay. Okay. If there's no questions, I will finish until here. So thank you for coming.